morning, dear students. Today we will start with our new chapter, that is some basic concepts of chemistry. Remember, this is your first chapter of NCERT textbook, which involves a lot of numerical problems. So don't worry about these numericals, because if you remember the formula of the chemical term, then very easily you can solve the numericals. Numericals involved will be based on calculation of number of moles, or calculation of molarity, or calculation of molality, or calculation of mole fraction, or calculation of mass percentage, or calculation of volume percentage, or finding out the molecular formula of the given compound if percentage composition of elements present in the given compound are given. So here in this chapter we will be having lots and lots of numerical. So let's start with this chapter, and here topic first is your mole. This topic mole was introduced in class 9 in chapter atoms and molecules. So let us revise what is mole. So point number 1, it is a pure number. It is not molecule. It is a number, and this number is always equals to 6.022 into 10 to the power 23. Okay, a mole is a pure number which is a collection of 6.022 into 10 to the power 23 particles. It can be any particle. It can be atom. It can be ion, it can be molecule, it can be proton, it can be neutron, it can be electron, etc., etc. So if I write 1 mole atoms, then how many atoms will be there? Just replace term 1 mole by this number 6.022 into 10 to the power 23. So when I talk about 1 mole atoms, then I am talking about 6.022 into 10 to the power 23 atoms. If it is 1 mole molecules, it means how many molecules will be there? There will be 6.022 into 10 to the power 23 molecules. And if I talk about 1 mole ions, then it will be 6.022 into 10 to the power 23 ions. It can be 1 mole electrons. Then the number of electrons I am talking about will be 6.022 into 10 to the power 23 electrons. It can be 1 mole protons or 1 mole neutrons. 1 mole protons means 6.022 into 10 to the power 23 protons, and 1 mole neutrons means 6.022 into 10 to the power 23 neutrons. It can be 1 mole marker. If I am writing 1 mole marker, it means I am talking about 6.022 into 10 to the power 23 marker. Remember, it is a very, very big number. You cannot imagine it. It's such a large number. And important point here, the number 6.022 into 10 to the power 23 is also called Avogadro's number. This number is also called Avogadro's number. After that, let us move to atomic mass and gram atomic mass. You know it very well that atoms are not visible. Atoms contain 3 fundamental particles, or we can say subatomic particles, and the subatomic particles are electrons, protons and neutrons. At the center of the atom we are having nucleus. And in the nucleus we are having subatomic particles like protons and neutrons, and outside the nucleus, it means in the extranuclear region, we are having electrons which are revolving around the nucleus. Now, mass of electrons are negligible. It means electrons never contribute in the mass of an atom. The mass of an atom is only due to the number of protons and the number of neutrons. So protons and the neutrons are the massive subatomic particles of the atom. So mass of an atom is always contributed due to mass of protons and mass of neutrons. Clear? So here, atomic mass. The mass of an atom is called atomic mass, and its unit is AMU, which is called atomic mass unit, or now it is replaced by U, which is called unified mass. Mass of proton and mass of neutrons are nearly same. And for mass of proton and mass of neutron, we can use 1 AMU. Now suppose an atom is having 1 proton, then its mass will be 1 AMU. If an atom is having 2 protons and 2 neutrons, then its mass will be 4 AMU. 1 AMU from first proton, 1 AMU from second proton, 1 AMU from first neutron, and 1 AMU from second neutron. And this 1 AMU or U is always equals to 1.66 into 10 to the power minus 24 gram. It means this mass is very, very less. That's why we cannot feel an atom. We cannot see an atom. And we cannot feel an atom. So dealing with atoms during calculation is not convenient. But if collection of atoms are taken, then it becomes convenient to deal with the atoms, because the mass we are obtaining for the collection of atom can be used for calculation purpose. So let us move to gram atomic mass. The mass of an atom when expressed in grams is called gram atomic mass. It is the mass of 6.022 into 10 to the power 23 atoms, and is also called elemental mass. Like for hydrogen, if the atomic mass is 1 AMU, then its gram atomic mass will be 1 gram. The atomic mass is converted to the gram value. Now how we can convert such a small mass to such a high mass, a large mass? 1 AMU is simply 1.66 into 10 to the power minus 24 gram. But 1 gram is a big mass if compared with this value. So how this 1 AMU is converted to 1 gram? For converting 1 AMU to 1 gram, we will take collection of 6.022 into 10 to the power 23 hydrogen atoms. When 6.022 into 10 to the power 23 hydrogen atoms are taken together, then the mass becomes 1 gram. So gram atomic mass is always the mass of 6.022 into 10 to the power 23 atoms. Like for carbon, inside the nucleus we are having 6 protons and 6 neutrons. So mass can be written as 12 AMU for a single carbon atom. But whenever we are dealing with the calculation, we are always provided 12 gram of carbon. And 12 gram represents gram atomic mass of carbon, or it is the elemental mass of carbon. So how 12 AMU is converted to 12 gram? For this conversion, we will require collection of 6.022 into 10 to the power 23 carbon atoms. When 6.022 into 10 to the power 23 carbon atoms, each carbon atom has a mass of 12 AMU or 12 into 1.66 into 10 to the power minus 24 gram. So when 6.022 into 10 to the power 23 carbon atoms are taken together, then the mass becomes 12 gram. This mass is called gram atomic mass, 12 AMU to 12 gram, and we need 1 mole of atom. And this mass is called elemental mass. This mass is called elemental mass. Similarly for nitrogen, inside the nucleus we are having 7 protons and 7 neutrons, so its atomic mass is 17 AMU. But whenever we are dealing with the calculation, we are always provided nitrogen, its atomic mass is 14 gram. So what's the meaning? It's very simple. 14 gram of nitrogen means we are having collection of 6.022 into 10 to the power 23 nitrogen atoms. When such a large nitrogen atoms are taken, such a large number of N atoms are taken, then its mass becomes 14 gram. And this is also called elemental mass. So whatever we are seeing in the periodic table, it's not the atom, it's the element. It is the element. Because atom is not visible, but elements are visible. You can see gold, you can see silver, etc., etc. Then comes calculation of number of moles. How to calculate number of moles? Its formula is very simple. Number of moles equals to mass given divided by gram atomic mass. Remember, gram atomic mass for each and every element is having a constant value. We cannot change it. Because we cannot change the number of neutrons and protons inside the nucleus. That's why the gram atomic mass is fixed. Atomic mass is also fixed. That's why gram atomic mass is fixed. Now, how to calculate number of moles? Like for carbon, its gram atomic mass is 12 gram. And you are provided 24 gram of carbon. Then how many moles will be there? Because in 12 gram, we are having 6.022 into 10 to the power 23 carbon atoms. We are having 1 mole of atoms. We are having 1 mole of carbon atoms in 12 gram. So definitely in 24 gram it will be 2 moles of carbon atoms. So mass given is 24 divided by 12. It will be equal to 2 moles of carbon atom. So in 24 gram of carbon atom we will be having 2 into 6.022 into 10 to the power 23 carbon atoms. For nitrogen, if you are provided 34 gram of nitrogen, then what will be the number of moles? Simply 34, the mass given for the element, divided by its gram atomic mass, it is 40. So 28 gram of N is provided. So mass is 28 divided by 40. Again it will be 2 moles of N atom. 2 moles of N atom means we are talking about 6.022 into 10 to the power 23 nitrogen atoms. In this manner, number of moles for the element will be calculated if mass and gram atomic mass is provided. That's all for today. Thank you.